Exploratory and Sentiment Analysis of Netflix Data. Abstract. The term exploratory and sentiment analysis is a conjunction of two separately unique approaches present in the vast field of data science. The key to this project is to enhance the value of the data being utilized. In our case it is Netflix data, which is an open-source data set obtained from Kaggle that was wrangled and exercised to derive maximum insights using EDA exploratory data analysis and sentiment analysis after the amalgamation of two additional sets, Geographical Latitudes and Longitudes and Netflix Title Critics/Reviews dataset. The project is made using different utility analytical tools present in Python library of versatile packages. This paper introduces systematic and insightful usage of methods for exploratory data analysis and sentiment analysis by utilizing various packages concerned. Keywords: exploratory data analysis, sentiment analysis, data analytics, Python, Seaborn, NumPy, TensorFlow, Keras. Introduction. The term data analysis is known to be rooted in the statistics space, which itself is known to have a long history. With the help of the statistical development techniques, we can derive interesting outcomes. The advancement of rapid technological implications in the world led to a consequent advent of big data. We are constantly being faced with enormous amounts of raw data which is subject to future enhancements based on the required parameters and criteria by an entity. Starting with the collection of data, the most common and subsequent step is to perform the analysis of it. Data analysis is hence known to be a scientific process solely focused on the data as its subject. It begins with retrieving data from various external internal sources and then performing intrinsic analysis with the data in order to discover and obtain beneficial information catering the needs of an entity. For example, the analysis of population growth by district can help governments determine the number of hospitals that would be needed in a given area. When collecting the optimal data for analysis, it must hold the minimum viability in terms of features and attributes suitable for our analysis. This can be represented in terms of bodily and health-oriented features like health status, age, male-female ratio, BMI, etc., will provide much more issue-specific insights over the population. It can enable a person to visually represent these features as per the requirements. Fundamentally, there are two primary methods for data analysis based on the nature and characteristic of data: a qualitative data analysis and quantitative data analysis techniques. These data analysis techniques have the scope to be utilized independently or in combination with other methods in order to gain access to some of the best business and intelligence-oriented insights for making better decisions over the already present data. Data analysis as a subjective matter. Requirements gathering. The data is the necessary requirement for providing inputs to any type of analysis. It can be based on the requirements and parameters based on the user. This data can be either numerical or categorical. The purpose and scope can range from supervised to unsupervised learning. Data collection. The required data can be collected from a wide range of sources. It can be structured based on the criteria provided by analysts to custodians of a particular data set. The data can be man-made or in the form of technological output over utility, sensor system tracking, and many other implications. Data processing and cleaning. The data, when purported for utilization, must be processed on the level where the needs for analysis are satisfied. This includes placing data in the form of rows and columns that are human understandable in nature. Further, it must be cleaned for getting rid of any redundant data, or minimize the presence of anomalies prior to the deployment of the data for analysis. The figure given below explains these four fundamental steps in a lucrative pictogram. Figure 1.1, Relationship of Data, Information, and Intelligence. Source: Wikipedia. Literature survey. With the advent of technology, the need for consumption of data has increased tremendously. Every single activity of our life has become interlinked with data. As the famous British mathematician Clive Humby once said, "Data is the new oil." As interesting as it may sound, the fact that there is a constant need for intelligent solutions with data as inputs cannot be neglected. Due to these changes, we have witnessed a paradigm shift in almost every single field around the world. One such field is the entertainment industry that had a rapid transposition as the industry soon began to adopt virtual methods for releasing its content. The over-the-top, OTT, as a means to provide and deliver content has gained huge prominence around the world. One of the key players in the game being Netflix, has changed the way people subject themselves to entertainment. The from-home all-in-one package type subscription services that these OTT platforms has to offer had customers glued to them quite literally. All these behavioral information about large base of customers is essentially a valuable data. Thus, our project focuses on deriving crucial insights from the publicly available Netflix dataset, obtained from Kaggle 6. We have also made use of Geographical dataset and Netflix title reviews dataset. Exploratory data analysis. Once our required datasets are generated with inculcated properties like optimal, structured and human understandable data format, we can now proceed further for an in-depth analysis of it. To begin with, we have chosen EDA as our primary step to analyze our data. We have applied a variety of techniques to gain maximum insights from our dataset. From figure 3.1, the darker colored regions represent less correlation and lightest color represents highest correlation. Which essentially means that the above selected attributes are interrelated to such an extent that indicates us about the dependency factor within them. Thus, medium to high-ranged correlation attributes can be utilized for our analysis to derive interesting patterns. The features like IMDb_votes and IMDb_score have medium red color, which is neither too dark nor too light in contrast, indicating us that there is a variation in terms of them both. I.e. number of votes doesn't directly mean IMDb_score is higher, the quantity of the votes may. From the figure 3.2, we can understand the two main categories of formats that are present in Netflix. Using the SNS plotting method, we can find out that number of movies are about 2.5 times the number of series in the Netflix platform. The x-axis has the labels for series and movie, whereas the y-axis consists of the count of these formats. From the figure 3.3, we can understand the range of titles, both series and movies combined, in terms of their IMDb score. We can comprehend that the highest number of titles range from IMDb_score 6.4 to 6.8 in the given dataset. The x-axis has the label for IMDb_score, whereas the y-axis consists of the count. Netflix logo is utilized as the mask. In the figures 3.4.1 and 3.4.2, we have generated word cloud for the first case, where the relevance of genres is mapped. Highest count genre is represented in larger font size and lower relevance is smaller. Similarly, using mask equals img feature in the word cloud method, we have mapped our genres into the Netflix logo for better graphical representation. The figures 3.5.1 to 3.5.4 shows us the titles in the given dataset in terms of their box office outcome. This is mapped by the correlation between Hidden Gem score and IMDb score, as these two features gives us the better idea whether the title was a box office success or not. The figure 3.7.1 shows us the folium plot of world map, where the above funnel plot data is mapped on a real map. As we hover and click on each country, those present in our dataset 35 NOS, we get the country name and number of Netflix titles. Using this, we can get a geospatial interface to visibly understand the country-wise know of titles. Sentiment analysis. After performing EDA, we have decided to utilize and expand the outcome of the project by inculcating sentiment analysis based on the series/movie reviews dataset for training set and summary attribute of Netflix data as the input/testing data. As the above EDA catered to our pre-processing needs, wherein we extracted the useful features, we have now combined three datasets together to form the training set, and we will use one of those three datasets as a testing set to obtain the classified data, result of our sentiment analysis. Results. By utilizing the EDA approach towards the Netflix data, we have garnered some crucial insights for other useful purposes. The following are summarized points. We have successfully cleaned the redundant records by removing them, and filtered the data set by discarding unused features. We developed a correlation amongst the utility features and established a guidance for our analysis. Built a plotting for size of series and movies in the dataset and also plotted IMDb_scores based on their relevance count. Created a word cloud both unmasked and masked based on the relevance of the genres in the dataset. Insights based on superhit, hit, average and flop box office status of a title using IMDb and hidden gem score as interlinked criteria, decided based on their correlation. Plotted the country-wise count of Netflix titles using funnel plot and developed a geospatial plot using Folium based on the latter feature. Built a sentiment analysis model by fitting the series/movie reviews dataset, which obtains the result by making use of the summary column in the Netflix dataset. Displayed the accuracy and loss of the above model fitting as a plot. Using the above methods and techniques we derived maximum results that are suitable for making better business decisions. Conclusion. Data analysis is a fundamental step to address the various needs of a client in any professional spectrum. The varied range of insights that can be derived from a data is itself primarily valuable in nature, as there are multiple businesses that are actively looking for futuristic, predictive, and descriptive insights from the already present raw data generated by them. It helps the organizations to gain access to numerous concealed patterns, information, and bits of knowledge after the analysis had been performed. The analysis that we have just performed using the Netflix data not only provides us with incentives to take smart and intelligent business decisions, but also contribute to the overall growth of the firm. These insights maintain a clear sight and perspective for various stakeholders and help in targeting a positive vision for the future. The future scope of data analysis is bound to remain intact as long as businesses require data science in their everyday applicable decision-making processes. Also, there is a great scale of possibilities when it comes to developing unique interactive solutions and methods that are confined to make data exploration much more intriguing in nature. These constant advancements have stabilized a promising direction for data analysis as a systemic study that is going to stay as long as there is the crunch for data in any viable field of study in the real world.